Today I'm going to explain a sum from homework 2. The sum says that when an analog signal is transmitted, there can be two inputs, X or Y. Suppose the probability of getting an X as an input is 0.6 and the probability of getting a Y as input is 0.4. Now when X is transmitted, the probability that the same X is received is 0.9, and when Y is transmitted, the probability of getting the same Y as output is 0.8. Now when a signal is transmitted, there can be many errors. So when X is transmitted, the probability of getting an error and getting Y as output is 0.1, and when Y is transmitted, the probability of getting an error and getting an X as output is 0.2. Now these are the four sub-questions that we need to answer. Probability. So these are the four sub-questions that we need to answer. First, the probability of getting X as an output. Second, probability of getting Y as an output. And C, probability of getting an error when X or Y both are transmitted. And D part, probability of getting an error when Y is transmitted. So let us explain one by one. First, probability of getting X as an output. So X can be we can get X as an output by two ways. First, if X is transmitted and same X is at output, the probability is 0.9, and Y is transmitted and then an error occurs and we get X as an output, so that probability is 0.2. So now if input is X and the output is X, then the probability is 0.9. So if X is chosen as input, the probability of getting X is 0.9, and at the output, if same X is X we get, then probability is 0.9. So 0.6 into 0.9 plus, if Y is chosen as input and there is an error so that we can get X, the probability is 0.2. So 0.4 into 0.2. Now we need to add both these things and we'll get the probability of getting X as an output. Now probability of getting Y as an output. Now probability of getting Y as an output can be by two ways. First, if X is the input and an error occurs and we get Y as an output. Secondly, if the same Y is been transmitted without any error. So by two ways we can get Y as an output. So 0.4 into 0.8 means Y is chosen as input and same Y is we get as output. So 0.4 into 0.8 is 0.32, and if X is chosen as input, the probability of getting X chosen as input is 0.6 into error of getting Y as an output when X is the input is 0.1. So 0.32 plus 0.06 is 0.38. Now probability of getting an error if X or Y is chosen as an input. Now if X is chosen as input, the probability of getting an error is 0.1, and if Y is chosen as input, the probability of getting an error is 0.2. So if X is chosen as input, the probability of error is 0.1. So 0.06 into 0.1 will be the probability of getting an error if X is chosen as input. Probability of getting an error if Y is chosen. If Y is chosen, the probability is 0.4, and probability of getting an error in that case is 0.2. So 0.4 into 0.2. So 0.08 plus 0.06 is 0.14. This is the probability of getting an error. Now the last part, the probability of getting an error if Y is transmitted. We need to find that. So we need to apply Bayes' theorem in this. So here we know that Y will occur while Y is chosen as input. So that part is fixed. So probability of getting an error if y is chosen is 0.4 into 0.2. Divided by, according to the Bayes theorem, we need to add both the inputs, probability of getting an error. So probability of getting an x as probability of getting an error in if x is input, and probability of getting an error if y is input. We need to add both of these things. So 0.4 into 0.2 is the probability of getting an error if y is input. This is given, divided by both x and y's error we need to add. So 0.6 is the probability of x into 0.1 is the error if x is the input. 0.4 is the probability of y into error when y is chosen. So 0.08 divided by 0.14 is equal to 0.5714 is the probability of getting an error if specifically y is chosen. Thank you.